In this paper I present RoboType, a software prototype to simulate single-finger text entry on touchscreen devices. Mobile text entry studies typically report results from lab-based evaluations, with relatively few exceptions referring to large, in-the-wild experiments. Although lab-based evaluations have traditionally been the de facto way to explore new mobile text entry ideas, they suffer from several disadvantages. One of these is the small number of users involved, which makes results difficult to generalize. Lab studies take considerable time and effort to organize, recruit participants and extract data from them. Because they are based on repetitive and somewhat artificial transcription tasks, participants can get quickly bored or tired of participating. Therefore, it's hard to bring them back multiple times and to observe longitudinal effects from using novel text entry methods. Therefore, a lab study is costly and doesn't allow the rapid evaluation of alternative interaction designs and ideas. To overcome this problem, past research has proposed theoretical modeling of mobile text entry. These models can simulate typing under different conditions and allow the rapid discovery of performance bounds through simulation. However, these models refer to performance bounds, precisely because they represent ideal conditions. For example, the simulated user is thought to suffer no penalty during text entry due to unfamiliarity with a keyboard layout, or due to errors in the input process because of tapping inaccuracies, or even the time and effort expended in correcting these errors. Models like these can offer rapid insights in the potential of a new text entry idea to outperform established methods. However, estimated differences still require validation through empirical studies. RoboType is a middle ground between lab empirical evaluation and theoretic modeling. RoboType aims to improve the simulation of mobile text entry by modeling users that do not have constant finger movement speeds as they perform typing, can make inaccurate target selections, that face cognitive challenges such as a difficulty to locate targets in an unfamiliar layout, who learn and improve through experience, and that suffer no human biases during an experiment, such as learning effects, preferences, tiredness, or boredom. With realistic synthetic users like these, researchers can perform simulated experiments that can involve hundreds or thousands of simulated users, in unlimited phrase trials from any imaginable corpus. These experiments can be fully replicable and reproducible, if desired, and require no special design such as counterbalancing or measures to accommodate ethical considerations. These simulations can generate large amounts of richly annotated input streams in a machine-readable output, making online and offline analysis easy. Best of all, this rich data can be produced in a matter of mere seconds, instead of taking days or weeks, as a typical lab study would. RoboType incorporates state-of-the-art knowledge about human behavior in touchscreen text entry and new stochastic models producing random but realistic behavior. Simulated user behavior is based on the F-fits law for touch distribution and the kinematic theory of rapid human movements. It also incorporates new models derived from the analysis of extant empirical data. These models are used to stochastically estimate human finger speed profiles during consecutive target selection, to calculate finger sliding upon taps based on finger velocity vectors, to factor in visual search times between target selections and to produce error-correcting behaviors, such as immediate detection and correction of input errors. Output from these models is random, following predetermined distributions. RoboType is written entirely in Python 3 and the code is easy to comprehend, extend and refine by any moderately experienced programmer. Its modular structure makes it easy to implement any keyboard layout and language. And most importantly, it is available as open source project to the community. To try out RoboType, a synthetic experiment was performed. This involved 30 virtual participants typing 50 randomly chosen phrases from the Enron mobile phrase set, with 3 alternative keyboard layouts, QWERTY, FITLY and OCTY. Setting RoboType model parameters to an ideal configuration, where users make 100% accurate touches and require no visual scan time to locate the next target, the results, in terms of words per minute, match the theoretical models in previous literature very closely. Setting the parameters to more realistic settings, the performance is close to that established in past empirical studies. Therefore, RoboType models for finger kinematics seem very close to real human performance. Working with RoboType is very easy. A synthetic experiment requires only 30 lines of code to set up and run. An experiment such as the one presented in our paper, involving 1500 phrases, only takes about 14 seconds to execute on a mid-spec laptop computer. RoboType can produce the complete input stream from synthetic participants as a JSON file that is easy to parse and compute metrics from. Optionally, the input stream can be visualized on screen over the keyboard layout, assisting the comprehension of produced output. All the necessary code and 30 pre-modeled virtual participants are provided with RoboType. We also provide sample XML layouts for 3 alternative keyboards, as well as code to read and pre-process 4 phrase sets commonly used in previous studies. Further, RoboType includes code to calculate backspace counts, words per minute and keystroke per second metrics. Finally, RoboType includes an experimental statistical decoder based on touch and language data, which can be improved and retrained on any corpus. Performance with the decoded is not examined in this paper. There are several limitations to the current implementations of RoboType, most importantly the fact that it models only index finger entry for now. Other improvements in the future may include a more complete model of human visual attention and memory recall, as well as models to simulate learning and improvement through experience. Further, RoboType could be paired with a generative AI system to produce dialogue between agents, in order to simulate actual conversations between users, rather than depend on various corpora for performance evaluation. Further, RoboType could be extended to model users from special categories, such as children, older adults, or persons with impairments, therefore facilitating research in these populations that are much more difficult to recruit for. I invite the community to explore RoboType's code and to further contribute to its development, so please check out the code repository following the link in the paper.